This is section 2.4b, significant figures in calculations. Oh, I'm sorry. Let me get my delicious Jimmy John's Italian nightclub sandwich out of your way here. That's good. Sorry. Previously on Days of Chemistry, recall that Johnny was discussing with Mary how to determine the number of significant figures in a number. Meanwhile, Frank, unbeknownst to them, was trying to calculate why this particular zero was not significant. Today, we discuss significant figures in calculations. Section 2.4b. Addition and subtraction. The answer must not have any digits further to the right than the shortest addend. What the? Let's take a look at this problem. In here we have three digits, 12.16457, 8.013, 2.11. Those numbers are known as addends. So the numbers that we're adding or subtracting, that's what we're talking about there. And in order to determine where we need to round our number off to, we look at where, as they put it, the furthest to the right. So if we look at significant digits in this first number, the number furthest to the right that's significant is that one. In this one, the farthest number to the right is that one. And in this one, the farthest number to the right is right there. So the answer can only have a digit no farther than the one that is the shortest to the right. In other words, right down here. That's where I need to round off my answer to. I kind of think of it like this. If I kind of draw an arrow like that, how far to the left do I draw it? Wherever the farthest is, that's where I got to cut off my answer. So I have to cut my answer off to the nearest hundredth. Now, I don't just cut it off. I don't just drop everything. I need to do the normal things that you do in math. You need to round it off. So for this one, my answer would be 22.29. Okay? Let's take a look at a math one, or a subtraction one, rather. If we have a subtraction one, here's what we get for an answer. What's the farthest to the right? This one. Which one's the farthest to the right? This one. All right, so then I got to look, well, I can only go that far. So I got to go there. So now I got to round off to the nearest whole number. Well, what is 16.9987 rounded off to the nearest whole number? It's 17. So in this problem, 17 minus 0.0013 gets me 17. Here's what we're saying. The problem is that even though this is a really good measurement, this one isn't. And any error in this one is, I could be at 16, it could be 18. It's kind of that, you made that estimate. Remember that last place is always estimated. Therefore, all of this good accuracy here means nothing. It's irrelevant. So I have to round it off to that far. Let's take a look at multiplication and division. Here it says, the answer must have the same number of significant figures as the factor with the least number of significant figures. Let's try to make this unconfusing. So, here we have 6.221, 3.4. How many significant digits do I have here? I have 4. How many significant digits do I have in this factor? I have 2. Which of these is smallest? That one. That's how many my answer can have. I don't care about the place. When we're adding, subtracting, place value makes all the difference in the world, and how many significant digits I have doesn't matter at all. When I'm multiplying, it's all about the number of significant digits. So in this case, I need to round it off to 2 significant digits. So here's 1, here's 2. So it looks like I'm going to round it off to the nearest whole number. In this case, that would simply be 21. So that's my answer of that multiplication problem to the correct number of significant digits. How about division? Here's an interesting thing. If you take 40 divided by 0.0013 on your calculator, you get like 30,769.230769230077. And actually, it probably goes much farther than that, but that's all the farther my calculator went. All right, so let's look at it again. How many significant digits in this number? If you said 2, you were absolutely right. How many in this number? 4. Which of these is smallest? 2. Therefore, my answer can have 2 significant digits. So I've got to round off to 1, 2. That's where I'm rounding off to. I'm rounding off, in this case, to the nearest 1,000. And so 30,769 rounded off to the nearest 1,000 would be 31,000. Don't lose these zeros. Remember, they're not significant, but there's a huge difference between 31 and 31,000. And if you don't believe me, I would gladly trade you $31 for your $31,000, which I think are different and you might think are the same. So they are definitely different. So this is my answer. No dollars. Okay, this is not my answer. It's your turn. Stop the video and do these 2 problems right now. You need to do them. Make sure you have rounded them off to the correct number of significant digits. I haven't done that yet, and if you didn't do that yet, you need to stop this again and do that. So let's take a look at the first one. How many significant digits? There's only 1, and in this one there are 3. Therefore, my answer can only have 1 significant digit. That's it right there, that one. So I would round it off to 0.3, and I would drop everything else. It's gone. Just gone out of here. On the next one, I've got 3, and once again, I only have 1. So my answer can only have 1 significant digit in it, so it would be 0.003. Again, another 3. It's quiz time. Still have questions? Watch section 2.4B, additional help.